Welcome to 15-Minute Discourse, where we take information overload and turn it into a deep dive you can actually enjoy.
Mm-hmm.
Today we're diving into a paper that kind of shook up the AI world back in 2017. Attention is all you need.
Oh, yeah, this one. It really did change things.
Published by some Google researchers.
Mm.
And it wasn't just about a new model. It was a whole new way of thinking about how AI understands language, right?
Yeah, absolutely, like a real paradigm shift. Before this paper, the field was so focused on recurrent neural networks, RNNs. For anything involving sequences of data, they were the go-to.
Okay, hold on. For our listeners who might not be, AI experts, sequence transduction, that sounds pretty technical.
Right.
Can we break that down a bit?
Sure. Think of translating languages. You're taking a bunch of words in one language, like English, and you're changing it into another language, like French. That's sequence transduction.
Right.
Or summarizing a long article and making it shorter. That's taking a long sequence and making it a short one. Same idea. Speech recognition, too. Sound to text. It's all about sequences.
So basically, sequence transduction is everywhere. But you're saying RNNs weren't really doing the job well enough. What was the problem there?
They had some limitations. Imagine you're reading a book, but only one word at a time. You might miss the bigger picture, right?
Yeah, you'd lose the plot.
Exactly. And RNNs, because they process things step by step, they had this issue with long-range dependencies. Like, a word at the beginning of a sentence could be super important for understanding something at the end, but the RNN might kind of forget it along the way.
Right, so a word way back at the start is like lost in the noise. And that's where this whole attention thing comes in, right? It's kind of like how our brains work. We don't focus on every single word equally. We pay attention to what's important.
You got it. That's the big idea in this paper. What if attention mechanisms on their own could handle this whole sequence transduction thing, no RNNs needed, and they built the transformer architecture to prove it could be done?
Okay, I'm intrigued. But before we get into all the details of the transformer, what was so groundbreaking about getting rid of the RNNs? Did it just speed things up, or was there something deeper going on?
It was a fundamental change. Like, RNNs were like having one really good translator working line by line, very thorough but slow.
Okay, I get that.
But the transformer with this attention thing, it's like having a whole team of translators all working on different parts of the text at the same time.
So it's more parallel processing, like dividing and conquering.
Exactly.
Okay, that makes sense. So walk me through the core of this transformer. What's this encoder-decoder setup they keep talking about?
So it's a two-step process. The encoder, it goes first. It takes the input sequence, let's say an English sentence, and it creates this really detailed representation of it, capturing all the meanings and the connections between the words.
Okay, so it's like figuring out what the sentence is all about.
Right, exactly. Then the decoder comes in. It takes that representation that the encoder made, and it uses it to generate the output sequence, which could be, say, a French translation.
So encoder understands, decoder translates, and the secret sauce in both of these steps you're saying is attention.
Exactly. Instead of RNNs, the transformer uses these things called stacked self-attention layers.
Stacked, okay.
So basically, each word gets to look at all the other words in the sentence and figure out which ones are most important for understanding its meaning. It's like each word is having a little meeting with all the others.
That's a cool way to think about it.
And this is how it deals with those long-range dependencies that RNNs had trouble with. It can see the whole sentence all at once.
I see. So no more forgetting important words from earlier on. This is starting to sound like a pretty big deal, but self-attention, can we dig into that a bit more? How does a model figure out which words to actually pay attention to?
Well, it's all about calculating scores. For each pair of words, there's a score that shows how much one word should pay attention to the other.
Okay, so each word pair gets a score.
Right. And these scores, they're based on things like how similar the words are and their position in the sentence. Then these scores are turned into weights, so the connections that matter most get emphasized.
So it's like each word is voting on which other words are the most important to understanding it.
That's a great way to put it. And get this, the transformer doesn't just use one set of scores. It uses this thing called multi-head attention.
Multi-hit, like it has multiple personalities.
Kinda. It's like having several committees of experts, each focused on a different part of language.
Okay, so different committees for different aspects of language.
Yeah. One might be looking for grammar stuff, another for meaning, and so on.
That's pretty wild. It's not just mimicking how we understand language. It's like it's developing its own kind of understanding, right?
That's an interesting way to think about it, for sure. And this multi-headed approach, it lets the model pick up on these subtle nuances that were really hard to capture before.
So it's like having a team of specialists all working together. In the paper, they mentioned that the transformer was beating everything that came before it on machine translation tasks. Can you give us an example of how big of a deal this improvement was?
Sure. One really impressive result was on the WMT 2014 English to German translation task. The transformer got a BLU score, which is how we measure translation quality, of 28.4.
Okay, 28.4, what does that mean in real terms?
Well, it was way higher than any other model at the time, a significant margin.
Wow, so not just a little bit better, but a whole lot better. But we've talked a lot about how the transformer works. What about the results? Like, why was this paper such a big deal in the AI world?
It wasn't just about better translations, though that was huge. It was about efficiency. The transformer, it needed less training time, less computing power compared to the older models.
Oh, so it was faster and cheaper to run.
This made it a lot more accessible for researchers and developers, which is really important for progress in any field.
So it was like a double whammy, better results and more efficient.
Exactly. And it's not just that. The transformer's success, it wasn't limited to just translation. It had this amazing ability to generalize to other tasks, too.
Oh, really? Like what?
Like parsing, for example.
Parsing. Remind me what that is again.
It's basically analyzing the grammatical structure of a sentence, breaking it down into its pieces like noun phrases and verb phrases. It shows you how a sentence is put together.
Right, right. So not exactly something you'd think a machine translation model would be good at.
Exactly. But the researchers, they tried applying the transformer to this parsing task, and guess what? It did incredibly well.
No way. So this model, designed for one thing, suddenly became good at something completely different. That's wild.
It really shows the power of attention. By learning to focus on those relationships between words and understanding the context, the transformer basically learned the fundamental rules of language.
So it's like it went beyond just translating words. It started understanding the structure of language itself.
Right. And this is what's so exciting about the transformer. It opens up all these new possibilities for AI, going way beyond what we could do before.
Okay, I'm all ears. What kind of possibilities are we talking about?
Imagine AI that can not only translate languages, but can also write different kinds of creative content. Imagine AI that can write stories, poems, even scripts.
Wow, that's pretty mind-blowing.
Or think about chatbots. With the transformer, we can create chatbots that have much more natural and engaging conversations.
That would be a huge improvement over the chatbots we have now.
And even more, AI that can analyze complex documents like legal contracts or scientific papers.
So we're talking about AI that doesn't just process words. It actually understands them in a way closer to how humans do.
Exactly.
That's both incredibly exciting and a little bit scary, to be honest.
I understand. There are definitely ethical implications that we need to consider very carefully. As AI systems become more powerful, we need to make sure they're used responsibly and for the good of everyone.
Absolutely. But for now, let's focus on the technical side. You mentioned the transformer being applied to this parsing task. Can you explain a bit more about what the researchers found and why it was so significant?
Sure. So they took the transformer, which was originally designed for translation, and they applied it to this constituency parsing task with only minor tweaks.
Okay, so minimal changes to the model.
Right. And what they found was that the transformer performed incredibly well, even better than models specifically built for parsing.
Wow, so it was like this model that was supposed to be good at translating could also analyze the grammatical structure of sentences with amazing accuracy.
Yes. And this was a big surprise because parsing requires a very deep understanding of grammar and syntax.
So it was like this model, just by learning to translate, had also learned the underlying rules of grammar.
It seems that way. And this was a huge finding because it showed that the transformer's ability to understand the relationships between words went way beyond just translating them. It was actually grasping the fundamental structure of language itself.
That's a really profound insight. It means that the transformer isn't just a tool for translation. It's a more general-purpose tool for understanding language as a whole.
Exactly. And that's what makes it so groundbreaking. It's not just about better performance on specific tasks. It's about the potential to understand language at a much deeper and more versatile level.
Okay, I'm starting to see why people were so excited about this paper.
Mm-hmm.
But every breakthrough has its limitations, right? What were some of the challenges that the researchers highlighted?
Well, one of the main limitations is computational complexity, especially when you're dealing with very long sequences of text. Remember how self-attention works, where each word has to compare itself to every other word?
Yeah, I remember.
Well, the problem is that as the sequence gets longer, the number of calculations grows really fast.
So it's like trying to have a conversation with 100 people at the same time. It just becomes too much to handle.
Exactly. And this becomes a real problem when you're dealing with things like processing an entire book or a long document.
So the transformer, while it opens up all these amazing possibilities, also comes with its own set of computational challenges.
Right. But the good news is that researchers are already working on ways to address these limitations.
Oh, that's good to hear. What kind of approaches are they exploring?
One promising approach is called restricted self-attention.
Restricted self-attention, what's that?
It basically limits the number of words that each word has to pay attention to.
So instead of looking at the whole sequence, it focuses on a smaller window of words.
Exactly. This helps to reduce the computational burden without losing too much information.
So it's like breaking down that giant conversation into smaller, more manageable groups.
That's a good way to think about it.
Right, so while the transformer has limitations, there are also promising solutions on the horizon.
Yes, and these new techniques are already showing great results, allowing us to apply the transformer to longer and more complex texts.
That's exciting. Now, we've talked a lot about the encoder and self-attention, but what about the decoder? What exactly does it do, and how does it use attention?
The decoder's job is to take that rich representation that the encoder created and use it to generate the output sequence. It's like a writer who takes all the raw ideas and information and crafts it into a beautiful and coherent piece of text.
So it's not just about spitting out a word-for-word translation. It's about understanding the flow and structure of the language to create something that sounds natural and fluent.
Exactly. And the decoder also uses self-attention, but in this case, it's focused on the words that it has already generated.
So it's like the decoder is paying attention to its own output to make sure it's making sense.
Yes. It's like a writer self-editing their work as they go along.
That makes sense. So we have the encoder, which is like the expert in understanding and context. And then we have the decoder, which is like the skilled writer who puts it all together.
That's a great analogy.
But there's another type of attention that you mentioned earlier, this encoder-decoder attention. What role does that play in this whole process?
Think of it this way. The encoder-decoder attention allows the decoder to look back at the original input sequence while it's generating the output.
So it's like the decoder is constantly checking back with the source material for inspiration and guidance.
Exactly. And this is super important for tasks like translation, where the order of words in the target language might be completely different from the source language.
So it's not just about understanding the meaning, it's also about figuring out how to express that meaning in a different language with its own unique rules and structure.
Right. It's like having a translator who not only understands both languages perfectly, but also has a deep understanding of how to bridge the gap between them.
This whole encoder-decoder setup with all these different attention mechanisms working together, it's truly a remarkable feat of engineering.
It really is.
It's easy to get lost in all the technical details, but I think it's important to remember that these models are ultimately created by humans.
Absolutely. The transformer is a testament to human ingenuity and our ability to understand and replicate the complexities of language.
It's a reminder that even the most advanced AI systems are still the product of human intelligence and creativity.
But it's also important to remember that these models are only as good as the data they're trained on and the people who design and use them.
Which brings us back to those ethical considerations we talked about earlier. The more powerful these AI systems become, the more crucial it is that we develop and deploy them responsibly, with careful attention to potential biases and the need for human oversight.
I completely agree. We need to make sure that AI is used for good and that it benefits all of humanity.
Okay, we've covered a lot of ground in this deep dive, but I feel like we've only scratched the surface of this paper and the world it's opened up.
There's so much more to explore about the transformer's impact and the future of attention-based models.
We've talked about how the transformer has revolutionized machine translation and opened up new possibilities in fields like parsing. We've also discussed the ethical considerations that we need to be mindful of as AI systems become more integrated into our lives.
The transformer was a pivotal moment in AI research, and its influence is only going to continue to grow.
And as researchers continue to push the boundaries of what's possible with these attention-based models, we can expect even more exciting and transformative breakthroughs in the years to come.
It's an exciting time to be working in this field, that's for sure.
Absolutely. But before we get too carried away with future possibilities, I want to go back to something you mentioned earlier. The paper mentions that they tested the transformer on a task that was very different from translation, this English constituency parsing thing. What was the significance of that finding, and what does it tell us about the capabilities of the transformer?
Yeah, that was a really interesting experiment. They wanted to see how far they could push this transformer thing, see what it was really capable of.
So what did they find out?
Well, constituency parsing, like we talked about, it's all about analyzing the grammatical structure of a sentence, breaking it down into its parts, noun phrases, verb phrases, all that. And it's a task that normally needs specialized models, something built for linguistics, not translation.
Right, like two very different skill sets.
Exactly. But they tried applying the transformer to this parsing task just to see what would happen. They didn't even change the model that much, just some small tweaks.
What happened?
It worked. The transformer did amazingly well, even better than some of the models that were designed specifically for parsing.
Wow, so it's like this model, just by learning to translate, somehow also learned how to analyze grammar.
It really seems that way. And this was a big deal because it showed that the transformer was doing something really special. It wasn't just translating words, it was understanding the underlying structure of language itself.
So like, even though it was trained on translation, it was picking up these deeper patterns of grammar along the way.
Exactly. And this is what makes a transformer so powerful. It's not a one-trick pony. It's a versatile tool for understanding language at a more fundamental level.
Okay, that's pretty mind-blowing. What are the implications of this for the future of AI? I mean, where can we go from here?
Well, it opens up all sorts of possibilities. Think about AI systems that can not only translate, but can also analyze complex legal documents, understand poetry, or even write different kinds of creative content.
AI that can actually comprehend language, not just process it.
That's the goal. And with attention-based models like the Transformer, it feels like we're getting closer and closer.
That's really exciting, but also a little daunting, you know? As these systems get more sophisticated, we need to be careful about how we use them,
Absolutely. We've already talked about some of the ethical considerations.
like bias and training data, the potential for misuse.
It's crucial that we develop and deploy these powerful AI systems responsibly.
Transparency, accountability, human oversight, all of that is going to be crucial.
Couldn't agree more. AI has the potential to do so much good, but it's up to us to make sure it's used for the right purposes.
Well said. Okay, I think we've covered a lot of ground today. We started with the limitations of RNNs, then we dove into this whole world of attention mechanisms, and we explored the Transformer's groundbreaking architecture.
We saw how it revolutionized machine translation and how it unexpectedly excelled at this parsing task, which showed its potential for more general language understanding.
And we talked about the ethical implications, which are going to become increasingly important as AI systems become more powerful.
It's been a fascinating journey, and it's just the beginning. The field of attention-based models is constantly evolving, with new research and breakthroughs happening all the time.
If you're interested in learning more, I definitely encourage you to check out the original Attention is All You Need paper. There's so much detail and insight there that we couldn't cover in our deep dive.
And there are tons of resources available online, too. It's an exciting field, and there's always something new to discover.
That's right. And if you enjoyed this deep dive on 15-Minute Discourse, please hit that like button and subscribe to our channel for more insightful explorations of the ideas that are shaping our world. Until next time, stay curious.